Okay, this is Michael Landis with Site Technical Community College. Um, Today we're going to discuss some after the fact air systems, as I call them. Their secondary air system is what the industry calls them. We're going to pump air into the exhaust system at various places in order to help decrease the emissions of the car. And so let's go over some old systems and the newer systems. The newer systems are a whole lot easier. The old systems did get a little bit complicated. Um, First off, why are we doing this? This is an emissions graph. This is what happens with our emissions. As our vehicle is running really, really rich, as it gets richer and richer, the hydrocarbons will start going up. So this one will actually continue up farther and farther. Um, the our NOx emissions when a vehicle is running rich is very low. But when it's running really rich, our HC and CO is real high. Well, then if the car's running real lean, those start to go back up again. The best place to get this is we're trying to find a happy medium right here in the middle for the two meanest ones, which is hydrocarbons, which is unburned fuel, carbon monoxide, which is the deadly gas that can kill us. That's CO. Don't confuse it with CO2. But as you can see, what happens is another emission that we have called NOx, or oxides of nitrogen, goes really high when this happens. Now, there's some other factors that affect NOx, but the main factor is temperature. It has to be really, really hot. The combustion chamber has to get hotter than it normally runs, but this will happen on a regular basis, like when you're driving the vehicle hard, when you're on a really, really hot summer day, you're climbing a hill. You've got a lot of load in the car. So this happens on a regular basis. So one of the ways that they found to combat that problem is the use of an EGR valve. That helped a bunch. The EGR valve helped bring down the combustion chamber temperatures. That brought the NOx down to acceptable levels. But on some vehicles, the problem was when the NOx was being created, we might have been in the throttle too hard to allow engine vacuum to actually open up the EGR valve. On today's cars, we'll use an electric EGR valve. The older cars, they were vacuum operated. So when the engine was under a load, there wasn't any vacuum to operate the EGR valve, and the NOx would increase. So one of the things they did to combat that is to come out with what was called a TWC, or a three-way catalytic converter. Three-way meaning it handled HCs, CO, and NOx. But what they found out is HC and CO, they could handle those a whole lot better with a lean air fuel mixture. And because we had to have oxygen to take care of them, but NOx was easier to handle if we had a little bit richer air fuel mixture. So you can see on the graph right here in the middle, if we could run it just a little bit richer, the NOx starts coming down really, really quick. So we need a lean mixture to take care of HC and CO, we needed a hot mix or a rich air-fuel mixture to help the converter take care of NOx. So we found a way to basically do all of those at the same time. And what we're going to do in order to handle that is we're going to use an air pump. At least this is the way we did it back then. And scroll down and get to the picture I want to show you here. So first thing they came out with was a air pump system. They decided, hey, let's pump air. If we can pump air into the exhaust, it didn't do anything to the engine. We had ways that we could make this work a whole lot better. And one of the first things they came out with was a air pump system. But one of the problems that they found with the air pump system is it did put a drag on the engine. We had to run the air pump. So they did come out with what is called a pulse air system. So in order to show that to you, I am going to pull up a picture of it. I could not find a picture that I really liked that I could use, and so I went onto the internet and I found some information about it. So I'm going to share that with you. I'm going to take you to the web page. That way I'm not really doing any copyright problems. I'm just going to share a page with you. And so I'm going to share my screen, and so you can see it. And this is the system. This was actually there were several versions of this system. This particular one started out in the 80s, and I'm going to blow this up a little bit for you here to enlarge this so it gets a little bit bigger so you can see it. And I'm even going to try to make it a little bit bigger for you. So I remember seeing these on several different brands of cars. The particular one that this drawing is, to me, looks like it's a General Motors 4-cylinder engine. It's fairly simple. There was no moving parts that you could see. What we did have, however, was a set of pipes. They went right into the exhaust manifold. And this came out before we had feedback systems. So before we had systems, computer controlled systems, this system was out there. We had to get rid of it when we started into computer controls for some obvious reasons that you'll see in a little bit. For one, we can't have air going into the exhaust in front of a oxygen sensor. So what we did was we put a set of pipes right into the exhaust manifold, and one pipe into each one. Then you can see the line pointing to the manifold pipes. Then at the end of those pipes, we had a check valve. This was a one-way check valve, so it would allow air to go from what says pulse air valve to the exhaust manifold, but air could not go from the exhaust manifold to the pulse air valve because of those check valves. So it would let air flow into the exhaust. It would not let air flow out of the exhaust. And we'll take a look at those check valves, what they do. They are extremely important to keep us from destroying other things in the engine compartment. But this system, it worked on the principle of when the exhaust valve would open up, piston would come up in the cylinder and push the exhaust out into the exhaust manifold. Then, as that exhaust started flowing through the exhaust system, the exhaust valve would shut off. Well, that doesn't stop the flow of exhaust. It kept moving, and since the valves were closed, right behind that pulse of air, that pressure of the exhaust gases that we just shoved into the exhaust pipe, it didn't automatically stop moving just because the exhaust valve closed off. It would keep moving and it would form a vacuum in behind it. That vacuum would pull the check valve open that you see here in the picture, and it would allow air to be drawn into that pipe in between each exhaust pulse. That's why they call this the pulse air system, because there was no pump. So there's no mechanical pump forcing air into it. We're just letting those little pulses of vacuum draw some fresh air in. And what that helped do is that helped heat up the catalytic converter, for one, to keep it up at operating temperature, because as we know, those have to be very hot in order to operate. The next thing it would do for us is the fuel coming out of the engine was still burning. Just because the exhaust valve opened up and the piston went up did not mean that the fuel stopped burning. Some of it was still burning, but it was getting ready to burn out because it was going to run out of oxygen. So by adding that little bit of oxygen back to it, it allowed some of that fuel to continue burning as it entered the exhaust pipe. And if we burn the hydrocarbons, then we don't have emissions left over afterwards. We get water and CO2. Nothing bad there going out. So the more of it we could burn, the better. That was the idea of this system. What was kind of the downfall of this is we came out with computers. Computers came out on the car and we put oxygen sensors in. Well, this system did not fare well with an oxygen sensor, because if you have air introduced into the exhaust manifold before the oxygen sensor, it gave it a bad reading. So we had to go to another system in order to combat that. The system that we went to is the most common one that we would see in the old on older vehicles, which was a full air pump system. And with this system, we put an air pump on the car. We also had to put a couple of valves on the car to keep the air pump from creating problems for us. So we started out with an air pump. The air pump has several pieces to it. What is missing off of this air pump is the pulley. Right here at the very front right here, in the middle, is right in this area, we would bolt the pulley on. You follow that line right in the middle, pulley would bolt on there, we'd put a belt on it, engine would run, it would turn the pump. Kind of like a fan, just take an electric motor, we put a set of fan blades on it. So this is just an air pump. there was a hole in the back here that air would come in. It would suck air in um, through the fins and push it right on through and back out the back side of the housing through a tube and into the exhaust manifold, the air cleaner, or to the converter, wherever we wanted to put it. If you ever get one of these, there's a couple neat things to point out. One, there is a vent hole on them. This is not to put oil in. Do not put oil in that hole. It is simply a vent for around the housing to make sure that it doesn't pressurize too much. And it gives it a place that it can spit some moisture out of it. Do not put oil in there. If you put oil into that pump, it could get hot enough, it could ignite the oil and set the pump on fire. So we do not oil this pump. It is permanently lubricated when it is built, and it never needs lubrication again. When it locks up, you just get another one. Now, the fins in the front are designed in such a way that no air filter was required. The idea was if there was any dirt in the air, if any dirt particles, dust, whatever was flying around it, this thing was spinning so fast that the fins would actually knock the dirt out of the way. The air would get drawn, it still get drawn in, but the dirt will be deflected. So there's not a whole lot to this guy. The biggest maintenance is, does it work? Can you turn it? If you can't, if it doesn't turn freely, and if you take the belt off of it, it should feel like there's nothing there. When you turn it by hand, you shouldn't be able to feel any pumping action like you may with a small engine. It should just spin freely, kind of like turning a fan blade on an electric fan with your hand. It should spin freely. If you feel little knots in it, there's probably something wrong in the motor. So then what we did with this system is we had an air pump, and there's some parts here that I want to point out to you. This is called a bypass diverter valve, and it's called a bypass diverter valve because it has two places it can, or actually three places it can send air to. It could send it to the exhaust manifold. It could send it to the air cleaner and just get rid of it, or we could divert it right back out to the atmosphere and get rid of it. Maybe we don't need it. So we're going to go through how this thing works. So when we start the car up cold, when the car is first started, before the oxygen sensor gets hot enough to work, air flows from the pump into the exhaust manifolds through a one-way check valve. There's those check valves again. These are just like the ones we use with pulse air. The check valves are there to keep exhaust from flowing backwards. So let me grab my little finger. If exhaust would flow backwards through this thing, the heat of the exhaust will melt this diverter valve. Plus, it could continue on to the air pump and destroy the air pump. I've seen both things happen. Up to the diverter valve, usually all of the lines are steel, and then there's usually just a rubber hose that hooks the line onto the diverter valve itself. So if that check valve goes bad, generally you'll find those rubber hoses will melt fairly quick. Usually what I would see is a customer would come in complaining about the noise because now they have an exhaust leak. And you'd open the hood up, and the rubber hose that hooks up to the beginning of the check valve. I'm grabbing my pencil here so I can draw it for you. And right here, the hose that hooks up here, this hose is usually rubber. So if this check valve goes bad, then as we would get exhaust that would flow through the check valve in that direction, coming back up, the heat of it will melt the rubber hose. If it gets up to the diverter valve, you need a handful of parts to fix it. You have to replace the check valve, you have to replace the hoses, you have to replace the diverter valve, the diverter bypass valve, and it can start getting expensive really quick. So we don't want those valves to go bad, but they often did. So back to the way this guy works. Let's erase my drawings here. When I first start the car up, what we're going to do when the engine is cold is we are going to have air. Air is going to come in through the bypass valve, and it's going to come right into the exhaust manifold right here. So that's before the catalytic converter. That is it's going right into the exhaust manifold, extra oxygen, cold engine, it's running rich, add oxygen, fuel, and lots of heat, and you're going to get a fire. So it keeps the fuel burning a little bit longer to try to burn off the hydrocarbons. Plus, it's going to add extra heat to the exhaust system to get this catalytic converter up and working as fast as possible. So the faster we can get that catalytic converter to heat up to operating temperature, then the better we can control the emissions going out of the tailpipe. One of the byproducts of that, it also helped heat up the oxygen sensor, because usually the oxygen sensor was right there after where these pipes were going in, and it heated up the oxygen sensor to get it on board. Now, once the engine gets hot and it goes into closed loop, remember, closed loop means we have a oxygen sensor that is warmed up, it's at operating temperature, it is responding. Soon as that happens, the computer will start making adjustments to our fuel system based on those oxygen sensor readings. So if we let that air keep going into the exhaust manifolds, we would always have a lean reading, and our computer would start adding more and more and more fuel. And I've seen some of these cars with a stuck diverter bypass valve that was putting air right into the exhaust manifold and never switched it down to the catalytic converter, and they had black smoke coming out the tailpipe just because that valve was stuck. You replace the valve and reset the computer, and everything goes back to working normally. So what we're going to do, this bypass valve right here, it is going to open up and allow, there's the bypass valve, highlight him in green. It's going to turn on either by vacuum or by an electrical signal, and it's going to send the air downstream now to our catalytic converter. But we're not going to put it into the front, we're going to put it into the middle of the catalytic converter, just to the middle of it, not up here up front, and it's not after it. It's right there in the middle, and I'll go over the reason for that here in just a second. So our airflow now is coming in. Our airflow is going to come in, go through the diverter valve, come through the line, through the check valve, and down into the middle of the converter. Now, this is what we call a TWC converter. That means three-way catalytic converter. Handles HC, CO, and NOx. To handle HC and CO, we needed a leaner mixture. Well, there wasn't any way that we could take the oxygen out of the exhaust to halfway through the converter to be able to handle NOx better. So the compromise to that was the first half of the converter handled NOx, and it does a better job with NOx if we have a richer exhaust system or basically a very low oxygen content in the exhaust. Extremely low oxygen content, and we did a better job of allowing the substrates that are in the converter to convert the NOx into a less harmful gas, something that we didn't have to worry about. But the converter had to have oxygen to treat HC and CO, so that was the purpose of pumping air right into the middle of it. All of a sudden, we added oxygen to the middle of the converter. So once it was treated for NOx, we added oxygen to it, and the rest of the converter could handle HC and CO very well, and we took care of our problem. So that's how we got what is called a TWC, which is three-way catalytic converter. The newer converters, they've gotten better with this. They're able to handle, just take the air-fuel mixture that they're given and handle NOx, HC, and CO. And we're controlling the engine so well now, we don't get near the amount of NOx that we used to get because we're controlling the fuel mixture so well. So if we go on to our next slide, it's a blow up, shows you a little bit bigger picture of what's going to happen when the engine is cold. Air goes into the exhaust manifold. When the air is hot, or rather when the engine is hot, then our air is going to be pumped into the middle of the converter. But one thing that we didn't show you, and here's a problem that I ran into, and it was usually due to, this thing is called a bypass diverter valve. It says bypass diverter valve solenoid. There was actually two solenoids in here. One was called a bypass solenoid, one was called a diverter valve. So as the air came in, the first thing it did was hit the bypass solenoid. Bypass solenoid decided, is the air going to go downstream, or are we just going to dump it back out to the atmosphere? Because think about what's going on. If I let off of the throttle real quick, we're going to have, on these older engines, we hadn't started shutting down injectors yet. A lot of these cars still had still had carburetors on them, so we could not stop the flow of fuel. So what we did is we just dumped the air out to the atmosphere. Now, generally there was a hose coming off of it that went up to the air cleaner, because if we dumped this air out to the atmosphere and we didn't muffle it somehow or another, it made a fairly loud noise because you could hear the pulsing of the air pump blowing, having the pulses of air coming back out of it. So what we ended up having to do was find a way to muffle it, and the easiest way to do that was we just put it in with the air cleaner. Hose generally went into the bottom of the air cleaner after the air filter. That way it just muffled the noise and the customers would not hear it. So bypass valve is going to decide, does it go downstream or do we dump it back out to the atmosphere and do nothing with it? The diverter valve does what its name is. It diverts it either to the exhaust manifold or to the catalytic converter. Fairly simple system. Not a whole lot went wrong with it. Generally, if I had a problem with these, it was usually either a vacuum line broke. Some of the diverter valves were vacuum operated. They would have a vacuum line that went over to a solenoid that was operated by the computer, and that vacuum line would rot, crack, get left off, what have you. That would cause the problems with it. That was fairly simple repair. The other problem that happened with them on a regular basis is the check valves would get dirty and they wouldn't close off. Now, hot exhaust gases would come back up, melt the hoses, melt the diverter valves. Sometimes they would damage the pump, depend on how long the customer ran them that way. Most of the time they came in pretty quick because you had this big loud exhaust leak up underneath of the hood. And it didn't sound like a normal exhaust leak. It had a lot of kind of grumbling to it. And it was just under the hood. It wasn't under the car. So that kind of alerted the customers they needed to have this thing checked on. Then we upgraded our system and we went to what we have now. This is a picture of a Chevrolet Corvette. It has a fan underneath of here. And now what we're doing is we don't have to worry about the converter getting air. All we have to do is worry about getting air into the exhaust manifold to help heat up the converter and help out a little bit with warming up the oxygen sensors. So systems are a whole lot easier. The fans, the pumps are not belt driven. They are actually driven by an electric motor. So the computer just turns on a relay, turns the fan on. This thing will actually sound like a hair dryer. Usually, unless you're out in front of the car, you won't hear it inside of the car. Usually with the hood boost, you won't hear the fan come on. But when the car is cold, the manufacturers say that the vehicle has to be cold, generally somewhere in the neighborhood of 40 to 45 degrees Fahrenheit, up to about 90 degrees. And if that's the ambient temperature of everything at startup, then we'll turn this fan on and pump air into the exhaust manifolds. That will help heat up our converter, get it online. The faster that converter gets heated up, the less pollutants we have out there. Then once the vehicle warms up to a predetermined amount, it's pretty much calculated. There's not a temperature sensor in there, and I've never found any listing that the engine has to reach a certain temperature. It's basically calculated catalytic converter temperature. So it's a calculation that the computer is doing based on the temperature at startup, and how long the engine has been running, how long the fan's been running, and it calculates the temperature. And as it gets hot enough to work, we shut the fan back off. Most of the time, these fans only run for 30 seconds to a minute or two, and that's about it. Now, every manufacturer I know of that uses this system says They only come on at cold startup. But I will tell you, I have seen them from several different manufacturers, and I won't name which ones. I've had them sitting in my bay with the vehicle idling, and I've noticed the pump will come back on when the car, after the car is warmed up. And I think what is happening, but it's not out there anywhere that I could prove it, is what is that if the car is sitting there idling or burning so little fuel now at idle with some of these engines that we really don't have enough exhaust heat to keep the converter up to temperature. And if it calculates that it is cooled down, then we will turn the fan back on, help heat it up. Usually doesn't last long. Most of the time that I see them on when the car is sitting there idling, it's generally been idling for a period of time, maybe about 5 or 6 minutes, and it probably wasn't already driven to begin with. It was sitting in the bay. I was working on it, but the car was just sitting there idling, and I noticed the little hair dryer came back on. Well, what'll happen when it does that, right before it comes on, the car goes back into open loop. The computer just put into open loop, turns the hair dryer on. We put some air down into the exhaust to heat the converter back up so it can do its job, turn the pump back off, and we go right back into closed loop. And other than hearing that fan run, you don't notice anything different has happened. That's pretty much our air pump system. It's not a whole lot to it. The biggest one I want you to kind of remember is this diverter valve, 3 places I can put it: air cleaner, exhaust manifold, or into the middle of the converter, depending on what I need it to do. Most of the time while you're driving the car, the air is going into the catalytic converter. When you let off of the throttle, it's going to go to the air cleaner. When the car is cold, it's going to go to the exhaust manifold. But keep in mind, if you see one of those, if that valve sticks, if the valve sticks and it keeps pumping air into the exhaust system, I've seen it cause enough of an explosion on hard deacceleration that I have seen it blow the holes in the muffler. It'll create enough of an explosion that it'll blow a hole in the muffler. More work creates more stuff that we get to fix, but the customer's really not happy with it when that happens. If it goes to the exhaust manifold, keep in mind that this car's in closed loop and it goes into the exhaust manifold, this car will never run at stoichiometric. It will never run rich as far as the computer is concerned, because we're pumping raw air right before the oxygen sensor, and it's going to run. The computer's going to think it's running lean. You may have black smoke out the tailpipe. It may run so rich you have black smoke out the tailpipe. So that's how this system works. It's fairly simple. There's no maintenance to it, other than if it's belt driven. If we have the belt driven piece, the air pump, only maintenance would be putting a belt on it, checking the belt, is it cracked, any of that. There's nothing else I have to do. All I do is fix it when it breaks. So with that done, we are done with the air pump system in our course of study that we're going over. So we're going finishing up the material that you've got going over these. The next thing that we're going to go over is we're going to start into the trying to remember, I think it is the evaporative emission system. There's a lot of different systems out there, and we're going to start covering those. But make sure you have this system down. Go in to Blackboard. You have in the next unit, there's a quiz on the air pump system. So go into Blackboard, get that done. And as always, any questions, you got my number, you got my email address. Send me a text message, call my phone. I'm talking to a lot of telemarketers these days, mainly hanging up on them once I figure out who they are. I'm even answering my phone when I don't know who it is now, because I know you guys are calling me. So give me a call. Any questions, give me a call, send me an email, what have you. I hope everybody's been safe, everybody's doing well. We will get through this, we will survive. Life is good. Take care. Landis out.